Hello, my name is Grant Kim, and this is my Physics 2212 Lab Report 3. And now, I will introduce the lab. The objectives of this lab are to predict, measure, and examine the behaviors of ohmic resistors and capacitors. And we will also use multimeters to measure values of conventional current and potential differences in closed circuits. The fundamentals of this lab include Ohm's law, which is voltage equals current times resistance, the node rule, which states that in a steady state, the total current entering a node is equal to the current leaving it, as well as the loop rule, which says that the sum of potential differences in a closed circuit is zero. A preview of the results show us that the loop and the node rules are proven true. It also proves that the magnitude of current in an RC circuit is dependent on time. And now we will get into the two experiments conducted for this lab. The materials required for this lab include two 1.5 volt C batteries which are connected together, one 1F capacitor, a series of alligator clips to connect our circuit, two light bulbs, and two multimeters. The assumptions we make for this lab are that wires have no resistance and that ammeters also have no resistance. This is a big assumption to make since we fundamentally know that all wires must have a form of resistance, but this assumption is necessary for the simplicity of this experiment and for calculations. The first experiment's objective is to observe change in energy conservation in series circuits. The starting conditions are that both batteries are connected to the ammeters by the alligator clips. The system of the experiment is the closed circuit, while the environment is everything else. The procedure for this experiment is very simple. We have to set up the circuit, turn on the ammeters, and then simply observe. The expectations are that the ammeter will display 0 megaamps. The results, however, show that the ammeter displays 0.13 mA. The objective of the second experiment is to observe how a capacitor affects a circuit. The starting conditions are the batteries connected to the two light bulbs as well as the capacitor. The system, like the previous experiment, is the closed circuit, while the environment is everything else. The procedure of this experiment is similar but not identical to the last experiment. First, we will set up the circuit. However, this time, we will time the charge and discharge of the capacitor by the glow of the light bulbs. The results of experiment 2 are as follows. The capacitor took 2 minutes and 10 seconds to charge, while it took 2 minutes and 6 seconds to discharge. Adding the voltmeter alters the circuit, but adding the ammeter does not. And now we will move on to the conclusion. Potential sources of error in this experiment include faulty ammeters, as well as accuracy in the measurements. The ammeter only displays current up to 2 decimal points, so there is the potential for some minor error in that regard. And now for a following question. What if we charged a capacitor with no resistor in the circuit? How quickly would our ideal model predict the capacitor to reach full charge? Would this prediction happen in real life? Without resistors, the charging and discharging of the capacitor would be instantaneous, as current would be free to flow without any inhibitors. However, resistance in the wires, as we know, still exists, and the perfect model does not take this into account. So, this would not happen in real life. Thank you for watching, and I'll see you next time.